not is equal to 0. This can be solved by a method called method of variation of parameters. Consider the homogeneous linear differential equation a0 of x into y double dash plus a1 of x into y dash plus a2 of x into y is equal to 0. That is equation number 2. Let the complementary function of 2 is yc is equal to c1 into u of x plus c2 into v of x. We assume the particular integral yp of 1 as yp is equal to a of x into u of x plus b of x into v of x. We have to find out the two functions a of x and b of x. To find these two functions, the method is given on the screen. Used to find the particular integral of a linear differential equation when the complementary function is known. Let the complementary function yc is equal to c1 u1 of x plus c2 u2 of x be the complementary function, a non-homogeneous linear differential equation with constant coefficients a0 into y double dash. Let yc is equal to c1 u1 of x plus c2 u2 of x be the is equal to r of x. Now we assume the particular integral of the second order non-homogeneous linear differential equation as yp is equal to a of x into u of x plus b of x into v of x, where a of x is given by a of x is equal to minus integral v of x into r of x by w dx, and b of x is given by integral u of x into r of x by w into dx, where w is the Branskin of u and v. W is equal to determinant of uv, u dash, v dash. If the given differential equation is a second order non-homogeneous linear differential equation with variable coefficients, that is a0 of x y double dash plus a1 of x y dash plus a2 of x into y is equal to r of x, then its yc is equal to c1 u of x plus c2 v of x. Then particular integral yp is equal to a of x into u of x plus b of x into v of x, where a of x into r of x by w into a0 of x dx. dx is equal to minus integral u of x into r of x by w into a0 of x dx, where w is the Wronskian.